Hello, this is Mrs. Pinkerton, and this is 2.4 Structure of Metals and Alloys. This unit, we're talking about metallic solids, and metallic solids are composed of cations surrounded by a sea of delocalized electrons. And I mentioned this a little bit in 2.1 when we talked about types of bonds. Their properties are ductility, that's the ability to be pulled into wires, and malleability, the ability to bend, and also that they're good conductors of heat and electricity. So again, we have these positive cations here, and we have these electrons that are able to move freely around the cations. So a sea of delocalized electrons. And that's what allows them to conduct electricity so well, the electron movement. So alloys combine two or more metallic elements, and not necessarily always metallic elements. For example, here we have an interstitial alloy, and that forms between atoms with a large difference in radii. And the smaller atoms fill the spaces between the larger atoms. So this is used to strengthen a metallic bond. So we talked about that malleability. This would make it not very malleable, because what happens is a smaller atom, and typically it's a non-metal like hydrogen, boron, or carbon, or nitrogen is added, and they're going to fit in between these gaps. And now all of a sudden these cations can't move as freely because these other atoms are blocking that movement. So here we have iron with an atomic radius of 126 ppm, and then carbon is almost half that at 70. And that's an interstitial alloy when you have a large difference in size. An example of this would be steel. And then we have substitutional alloys, and they form between atoms with similar radii, so similar size. And these are the ones that are typically two metals. For example, this one says copper and zinc, and here we have one that's 128 picometers and one that's 139. And they're similar in size. They don't have to be the exact same size, but we call that a substitutional alloy. So here's an example. Cupro-nickel is an alloy used to make coins. It is made of copper and nickel. The atomic radii of both elements are shown below. Illustrate the model that best represents this alloy and justify your answer. So what you're going to do is first, you're going to look at the elements and look at the radius. 128 and 163. And in atomic radii, it's not, there's about a little 30-ish difference there. That's not super big. So I would say, and they're both metals too, you're looking for a big difference in size for an interstitial alloy. So I would say this is a substitutional alloy, since the radii are similar in size. And it says illustrate the model. So if you want to draw this, it's good to make like a little key, say that's copper, and then nickel would be a little bigger, right? So you would just, draw the nickels, and then the coppers a little smaller. And it doesn't have to be 1-to-1 or anything, just that they're interspersed within each other. There's no like lattice that's like a ionic bond where you have that uniform lattice structure. Okay, that's all.